Hey, this is Philip. I'm one of the co-founders of Find AI. Find AI is a search engine for people and companies. On a normal day, we can make upwards of a few million requests to OpenAI. Scaling that level of usage has been a challenge for our team. And along the way, we've really adopted Velvet heavily within our infrastructure to help manage that. So today I'm going to walk you through some of the different ways that we use Velvet to help scale our OpenAI and general LLM usage at Find AI. On a given day, Find AI can call OpenAI a few million times. We use a variety of different endpoints ranging from moderation to batches to chat. And Velvet has become a core tool of our development and management. Within our overall OpenAI spend, our Velvet bill is about 3% of our OpenAI bill. So I really think of it as scaling proportionally to the usage of our OpenAI. But when we factor in the caching that Velvet provides, we're seeing that Velvet overall saves us money. So I put together a little demo of a simplified version of Find AI, and I'm going to push this to GitHub and include the link so you can follow along. So here's the application I built. It's a simple Ruby on Rails application. Find AI is built in Ruby on Rails, so it's the same stack that we use. And the way it works is you can search for a person or a company, and let's give it a quick whirl. Let's look for coffee shops in New York City. And that is a company, so we'll select company here. And I just use a quick OpenAI call to suggest some options. Starbucks, Blue Bottle, those are some coffee shops in New York. If we want to search for a person, we can say startup founders in New York City. We select people. There we go. We have some options from people in New York City. So I want to walk you through how we use Velvet to do some development with this toy application. And so I'm going to walk through how we would add a little feature here to use OpenAI to classify the search as either a person or a company search so we can get rid of this dropdown. To do that, I'm going to start by installing Velvet. So I'm just going to go to usevelvet.com, sign up for a new account, and create a new workspace. We'll call it Find AI Demo. So let's first create the gateway. So what Velvet is doing is creating a new database here. At Find AI, we use our own dedicated Postgres database to warehouse all of our own logs. But as you're getting started with Velvet, you can just use their hosted database right away. I'm going to create an API key here. I'm going to put it in a .env file. So I'm not going to show it on the screen here because this is my API key, not yours. Go get your own at usevelvet.com. And now I'm going to install Velvet in my repo. I have an initializer, OpenAI in here. Setting up Velvet just requires a couple quick steps. I need to set up the URI base here. This is how it works with Ruby. You can check your particular package. That is pointing our requests to Velvet. Velvet will then forward them on to OpenAI. And we also need to set the Velvet authentication header. This API key is going to come out of our .env file. And that should be it. Let's restart the server and try it out. So let's search for LLM providers. Search for companies. Here are some LLM providers. And going back over to Velvet, they've received our first log, which is great. So now we can go over to our logs here and see the actual request that happened. So we can say that I made the request, respond to this user query in JSON with a list of 3 to 5 companies. And then it returned here in the response some JSON response here. So it said OpenAI, Anthropic, Cohere, and that's what we saw in the UI. So that's working great. So we've got Velvet set up. Now let's use it for something a little bit more fancy. So what I'm going to do is go into the search controller and drop in a new OpenAI service that will replace this dropdown with an AI detection of whether we're searching for people or companies. So in our code, I have under app services, a search results service that calls OpenAI to say, respond to the user query in JSON with a list of 3 to 5 companies or people. And so I'm going to basically go through and make something similar here with a classify search query service. And so this is going to take in a query, and I'm going to have it call OpenAI here and say, given a user's query, your job is to determine whether they're searching for companies or people. Respond with JSON in the format of search type companies or search type people. Make a best guess, and always return one of those two. And then I'm going to go through and grab that answer here. I can go over to the searches controller here and say search.update and just call the service on this. And so that means I can go over to my searches new and get rid of this dropdown. So now I come back to this page and I can run a query of, let's say, best pizza in New York City. And here we go. We have some results. I don't know if I agree with the results, but those are some results. Jumping over to Velvet, we can go see our newest log here. So we can see that it said, given a user's query, your job is to determine whether they're searching for companies or people. And in the response, it gave us this response here, search type companies. We make a lot of requests with JSON at FindAI, so you can have OpenAI return valid JSON. And we use these debugging interfaces to understand what's going on in production. Oftentimes, when something doesn't behave how you expect it to, popping it open in Velvet like this is the best place to start. For instance, we've noticed issues in production when we set our temperature too high, where if the temperature is set too high, then we'll get some weird results from OpenAI. The other thing we've noticed is sometimes we get really long responses from OpenAI. So here I'm setting a JSON response type. We use JSON a lot. We've seen with OpenAI that on really long responses, sometimes it'll truncate the JSON and leave off like the last bracket or the last couple of characters. And that has really caused issues with our application. And that was the kind of error that we couldn't debug easily within our tools because we were expecting a particular response format. We weren't getting that particular response format. And OpenAI said they were sending it to us. And so we have been able to debug some of these production issues just by pulling up the actual responses from OpenAI. And that's really helped us out here. Cool. So I just showed you how we integrated Velvet and built a new feature. Now let's talk about how we measure and attribute AI costs. So one of the things that we think about within FindAI is attributing our OpenAI bill to the right services. We use Velvet really extensively internally to understand where we're spending our AI money. It's also important as we set up the pricing on our business. So with Velvet, we calculate a cost per search, we calculate a cost per user, and we also like to classify our different AI spend into research, marketing, or COGS. Those are different because if we're running OpenAI on our laptop, that's a research cost, that's development. If someone is logged out and using FindAI, that's really marketing because the person isn't a customer yet. And if someone is a paying customer, then we're calculating that as more part of our cost of goods. I'm going to go through and show you the main headers that we use to classify our OpenAI spend with Velvet. The first thing I like to do at the core of the application is to always add in a metadata env, meaning environments, point that to rails.environment here. And that'll just put into the logs whether this is a production request or a development request. There's different ways of handling this in production, but just putting this in is a really straightforward way that future-proofs these requests to make sure you know whether it's coming from development or from production. You see here that we have two different services calling OpenAI right now. I like to go in and add in the name of the file that's making the request as a header here so that within the logs, I can say, show me all calls from Classify Search Query Service, or from here, I can also say, show me all calls from the Search Results Service. We typically see that there's one or two files that cost most of our money in the bill. And so we can go in and target our optimizations to just those files and try to decrease the token usage. The other thing we want to do is analyze the data in the other direction and look at what is our cost per search. So what I like to do is go in and tag each search ID on each service that's making a call to OpenAI for that search. So let's go in here and add in the search ID here. And we'll add in the search ID here. So now when I run a search and say biggest startups in New York City, I can go over to Velvet here and we'll see that that metadata is being tagged on. So I can go in now and see the service was Classify Search Query Service for this call. The search ID was 13. The environment was development. So those are the three headers we just put in. So I can go to Velvet and ask what was the cost of search. 13, use the metadata search ID. And I can see total cost was a little under a penny. Now I can say break that down by the service metadata and see that our search results service is costing almost twice as much as the Classify Search Query Service. That's a quick demonstration of how we measure and attribute AI costs within Velvet. I showed you how we do it with search. You can easily layer in additional meta tags for users and organizations. And you can run more advanced analysis using the environment to understand your spend. The next thing I want to talk about is how we do some basic data analysis with OpenAI. So after each search is completed, we have a script that runs through and applies some tags to the searches so we can know what the person was high level looking for. For instance, were they searching based on geography, based on job title, based on market cap? We have tags that go through and categorize the high level queries that people are making. We could just run OpenAI after every search and ask it to tag the searches. But that could be expensive, and there's a cheaper way, which is OpenAI batches. OpenAI's batch functionality allows you to give OpenAI up to 24 hours to respond to a search, and it'll give you basically half off the price. And so at our scale, that's really worth it to be able to decrease the prices by half on these OpenAI calls. Batch API is relatively new from OpenAI. It can save you a lot of money when used properly, but it's a relatively opaque system. You upload files to a server and come get them later, and debugging what's happening can be really frustrating. It was frustrating until Velvet added batch support. So I'm going to walk through and show you how we use this within FindAI. So what happens is after a search concludes, we put it in a queue that says we want to go analyze the tags in the search. And what happens is we have a system that uploads files from this queue into the batch system at OpenAI. So you make one big file with a bunch of different items in it, and then you give it to OpenAI, and you check every hour for the next day until OpenAI has given us the response. And once you have the response, then we just go and add the tags to the search. Getting this functionality integrated into your application is a little bit more advanced, but if you know how cron jobs work, it's fairly straightforward. And the system works really well for us. We are able to wait 24 hours. And what we've seen with Velvet is that OpenAI advertises that it takes about 24 hours for results to come back, but we normally see the results coming back in closer to 3 hours. Velvet looks at those batch files that are being uploaded to OpenAI and breaks them apart by request and updates our unified data warehouse. And it makes it really nice to be able to get a clear, this is the request, this is the response, so that if we're having any issues with our batch data, we can go in and trace what happened. Without Velvet, there's not really an easy way to go do that. So now we're going to talk about how we go in and evaluate new models. Could we save money with a cheaper model? So right now I'm running this classification with GPT-4o. GPT-4o is more expensive than GPT-4o mini. And so we might want to go in and check, does GPT-4o mini do just as good a job as 4o? I'm going to show you how we run these evaluations in FindAI. What we do is we'll go in and download the results from one model and then rerun them with a new model and see if they're different. Let's do that. I'm going to go into our classify search query service. And my goal is to see if I can replace this model with GPT-4o mini to get the cost down. Here with Velvet, I can go in and grab a sample of actual user requests and actual classifications that we had with OpenAI, which is that healthcare startups in New York City is a company. So I can go in and download that as a CSV, and then I'm going to pull it into my application and be able to use real user data to inform these tests. What we do in production with FindAI is we have a smoke testing library that goes through and backtest our model changes on new data as it comes in. And we use the Velvet caching so that if the requests and responses are the same, we're not actually paying for OpenAI. But we can go in and make a little code change, like test a change from GPT-4 to O1 or something like that. And it'll immediately trigger retests of things and populate the caching library. And so that way we're able to really reliably make sure that some of our algorithms that do things like classification have an expected outcome. First thing I'm going to do is turn on the Velvet cache. What I'm going to do here is just do something quick and dirty though. Let's just add a little script that'll go through and test the requests and responses so we can play with it. Okay, so we've got some requests and responses. And so let's just pop this open in the Rails console and call verify expected results. Great. And now, because I've turned on the Velvet caching, I call it a second time. It should go a little faster because it's pulling from the cache. Great. So it's working. So now let's try swapping this out for GPT-4o mini. Let's see, does GPT-4o mini do just as well? That's great. So GPT-4o mini did just as well on this classification. In production, we would typically pass in more like 100 different tests for a classification algorithm like this. So by sampling requests that are actually being made in production, we can make sure that the algorithms are robust based on how people are actually using the service. What we do in production is we have a whole smoke testing library, but you could go into your continuous integration software and have it run the verify expected results on each of your models that have them. And we could have it raise an exception if it doesn't pass. This is how we do smoke testing on services that do tasks like classification, where there's an expected response format and a limited number of responses. We were able to just show that I could use a cheaper model and save money. And so that was really cool because I can immediately deploy this GPT-4o mini algorithm to production, knowing confidently that it's going to classify users' requests correctly. And I was able to do that by using Velvet to download the old results, run tests against them, and verify that it's working. What would happen if we saw a test failure here? What if GPT-4o mini didn't classify the user requests correctly? Fine-tuning lets you take a set of data that you know is correct and fine-tune a model so that the requests and responses more closely match the data that you provided. And so if GPT-4o mini isn't classifying our queries correctly, we can use some data that we know is correct to bring those responses closer to what we want. And to do that, we're going to use Velvet. We'll start with the smart model, make some requests through Velvet. Then we're going to download those requests from Velvet and then upload them to OpenAI to fine-tune GPT-4o mini. By fine-tuning, what we can do is substitute a more generic, expensive model like 4o with more of a unitasker model trained for one particular task like GPT-4o mini. So I'm going to go back to this original extract user messages query we had done and transform it with the Velvet docs into the formats that we need for the fine-tuning. And I'm going to go in and export all as JSON-L. We can just go over to the OpenAI dashboard, go to fine-tuning, and we use GPT-4o mini, upload our JSON-L file, and create it. And now we're fine-tuning. So keep an eye on this, and when it's ready, we'll be able to use the new model within our application. Double check the price of fine-tuning before you do it. As I'm recording this video, OpenAI is offering a promotion of free fine-tuning on GPT-4o mini, but really large models can cost a lot of money to fine-tune, so just double check those numbers ahead of time. And then when the fine-tuning is complete, you're going to get a new model ID that you can go in and drop in here that you can then run with your new model. So that's how you can use an expensive model to fine-tune a cheaper model using Velvet. That's an overview of how we at FindAI use Velvet to run our OpenAI requests. We went through and talked about how we use Velvet to gain visibility into our production logs, how we do cost analysis with Velvet, including its metadata tags, how we analyze batch calls, which we especially use for things like data analysis and tagging, how we evaluate new models, such as whether we can switch from GPT-4o to GPT-4o mini on particular services, and how we can use Velvet to fine-tune a less expensive model for particular use cases using OpenAI. If you found that interesting, come check out FindAI, try out the product. We're a search engine for companies and people, and we're also hiring. Thank you.